My name's Adria Wheaton. I'm with Utah State University's Center for Water Efficient Landscaping, and we've just started this this webinar series. Candace Scheibel is in Cedar City, and we have them once a month on every second Tuesday at 2, mostly so we can remember when they're at. Today we have Peter Mayer, and he's a professional engineer and urban water expert in the areas of water use, water efficiency, demand management, and water resource planning. He's the founder of Water DM for demand management, and he's based in Boulder, Colorado. However, he's worked all over the United States, Canada, and Australia with different water providers. Recently, Peter has published groundbreaking research on peak demand management through advanced irrigation control, and he's currently leading 3 research studies for the Water Research Foundation and the Alliance for Water Efficiency on meter sizing, outdoor water savings, and drought response. And today he's going to update us on the Outdoor Water Use Research Initiative of the AWE. So with that, I'll turn it over to Peter. Thank you, Peter.
So the Alliance for Water Efficiency, if you're not familiar with it, is a national nonprofit organization that really tries to bring together anyone who's interested in urban water efficiency overall. And that includes water providers, urban water professionals like myself, people from the green industry, people who use water, plumbing manufacturers, software developers, a variety of folks. Anyway, the entire focus is on urban water efficiency. And we all know that outdoor water use is really a key component of the urban water picture. And so the Alliance decided to develop a particular outdoor research saving initiative focused on outdoor water use. And so I've been leading this effort for the last couple of years. So today I'm going to talk about this project, some of the findings that we had from our initial research, some of the ongoing projects that we're doing, and also I'll tell you a little bit about the peak use study, which you can download the report from the Alliance, or which, if you're a member of the American Water Works Association, you can read about in the current May issue of the journal. So the idea of the Outdoor Savings Initiative is to do research which people can rely on, not just sort of, well, it worked in my backyard, so it's got to be true, to really try to do evaluations of programs that have been implemented in systematic ways and to determine what the real impact of these things. I've been involved in research on sort of this larger scale for quite some time, and you know, the findings aren't always what we're hoping to find. You know, I think some of the initial research with smart controllers bore that out, when we found that there wasn't necessarily as much water savings as people had hoped. So why do we want to get outdoor water savings? Because we know that it's the biggest single demand sector in the urban area. I mean, the urban landscape uses more than any other single thing, more than all the toilets in a city combined, particularly in the Western United States, more than all the cooling towers, things like that. So it's really an important area, and it's also the first one that will be cut back when there's a shortage or a drought. That's because it's discretionary, and so it's the one that can be most influenced. It's a lot easier to get people, or force people in some cases, to shut off irrigation rather than to make them, or ask them to take a shorter shower or do something like that. So that's why we focus on the outdoor use. We hope we don't have to get to the point of restrictions, and the idea is to sort of create an urban landscape that's more efficient overall. So the first phase of the research was to review published studies that were already out there. The idea was trying to get an idea of what had already been done, and so that we wouldn't duplicate that. So often we hear about really good research. It's just too bad that everybody's studying the same darn thing instead of spreading it out a little bit. So we didn't want to make that mistake. So this research was completed. This background phase 1 was research that was completed about 18 months ago, or maybe a little bit more. We found about 170 different studies that we thought were worthy of even reporting on, related to outdoor water savings. They kind of broke out into this pie chart of landscape transformation and restrictions and rates and education. monitoring and verification, system efficiency, and irrigation management. From this, some of our key findings were that, you can actually achieve significant outdoor water savings. There was quite a few studies that documented substantive changes in outdoor water use, 10%, 20% or more sometimes. However, actually quantifying the impacts was quite challenging, and not all studies successfully were able to quantify savings. Oh, I couldn't believe the phone would start ringing now. Anyway, the other issue is that there's quite a bit of variability or lack of variability in some of the areas where there's been research. Tends to be a lot of research in California, and generally in the Western United States. There's some really good research come out of Florida. But there's generally broad areas of the United States where we have very little data on specific water savings or programs. The other thing that was like cost savings or any changes in costs associated with a difference in landscape were very seldom documented. Where they were, though, was fascinating. So we often found that removal of turf actually resulted in the reduction in labor associated with the landscape when it was documented. So that also made us think that there could be some interesting findings there. Anyway, so it was clear there needed to be some more standardized approaches and some changes. So some of the areas of future need that we thought, that the two in yellow are ones that I'll be talking about later, because those are ones where we actually have new projects going. But the number one thing was, well, what really is the impact of, so what we're calling water-wise landscaping, versus traditional turf or higher demand landscapes on water use and on costs. And so that was sort of the number one question that was identified through the phase one. There was also quite a bit of interest in the impact of water rates and rate structures and billing information, and how that interacted with people's outdoor water use. And then there was particular interest in drought restrictions and what happened. This is largely driven by water utilities, who were very interested in knowing, what happens when you go from, unrestricted water use to 3 a day a week, to 2 day a week, to 1 day a week, to no day a week, to whatever restrictions you put in place. So that was another study identified. Also, people were interested in how low could we go? What are kind of the minimum water requirement and drought tolerances of plants and under different types of conditions? Sort of, can we optimize the landscape for a dry future, essentially? Those were the 4 top areas of need, and I'm happy to report that 2 of these were already underway with research. Other areas of need were what is the impact of landscape and contractor training, education, and certification? How are humans, how are Bill and Mary Sixpack interacting with their landscape and controller and irrigation system, or maybe are they not interacting? There was also interest in improving system efficiency, the impact of audits. And then one actually also that we're looking at a little bit through our landscape transformation project is the reasons and rationales for customer landscape choices. So why are people deciding really to change to a landscape that might use less water? How can water utilities and other interested groups perhaps incentivize that and change that further? Other areas, cost effectiveness, cost savings, regional variability, standard methods. I think I mentioned a few of these. And then, of course, I think the big one that hangs out there is the long-term reliability on projected lifetime water savings. Are these just savings that you're getting in a first year, 2 years, 3 years? Utilities, if they're going to pay for these or type of programs, are really interested if the savings are going to persist over a long period of time. And so that's also something that's very important to study. So a couple of areas that we thought were less important in terms of their need for research, because we already have some studies out there, were the impact of water budget-based rates. Pretty good research on that. They actually do work. and irrigation control technology, including sort of weather-based controllers and sensors. A lot of research has been done on these devices. I urge you to do your Googling and other research. It's quite available from Florida, from Utah, from a variety of other places where we can read really good work that's been done on these technologies, and they also work, although perhaps not always as expected. All right, so that was sort of the outcome of the phase one of the Alliance research project. We identified these areas of need for future research and areas that we thought maybe, well, we got enough there. Let's not start there at least. So that led us to phase two, and that's where we are right now. And so we formed a project advisory committee, and we started to develop a research program to address the gaps that we had identified. And we developed 2 requests for proposals, which we then sent around to different members of the Alliance and interested folks and raised some money. And so by getting contributions from the participants themselves, we were able to raise enough money to then put out the RFP for a public bid and develop the process and actually start implementing the research. So I'm going to tell you a little bit about the first 2 projects that we have underway, and then I'm going to close out by telling you about the third project, which is the peak water demand study, which has finished already, and so I can actually present some results on that. So the first project, where we put out an RFP, we're calling RFP number 1 very, very creatively, is called Reducing the Requirement: Landscape Transformation, Reasons, Rationale, and Water Savings. So the goals of this project are really pretty much stated in the title. It's like, what happens when you change your landscape? And so for this project, we're interested in, first of all, what starts that process, what motivates people to make the changes in the landscape. Then once that's done, what range of water savings or changes in water use can be expected from changing X square feet. And then what encourage those savings? Is it changes in the landscape itself? Is it changes in irrigation practices? The factors that might impact the different volumetric levels of savings, and then recommendations for how these water savings can be maximized. So we had quite a few. I don't think I've counted them all, but I think it's more than 9 or so water providers from mostly around the Western United States, but also from Canada, who are participating in this project and who contributed money. We got about, I think, more than 6 responses to the request, and ultimately awarded the project to a consulting firm called A&N Technical Services, which is based in San Diego area, and they have a really skilled researcher named Tom Chestnut, and his team is conducting this research among these participants. They're quite a far way along now, actually, and they've completed most of the surveys. They've collected a lot of data. When you're working in a multi-utility mode, it ends up being the type of research where you have to adapt considerably to the programs within each utility, which could be quite different. But I think we're going to get some very interesting results. A lot of these utilities have long-standing programs where landscapes have been changed over periods of 10 years or more. And so we're really looking forward to looking at some long-term data and being able to really hopefully remove climate variability as much as possible, to really be able to look at just the differences in the water requirements and the irrigation practices and what the water savings are. So that's the phase 1 research that's underway. That should be coming out probably toward the end of this year. I would expect that research to start emerging, and it's going to be a rich source of information for the years to come, I think. The second RFP, which is also well underway and should be coming out this year, is about drought response and the use and effectiveness of municipal irrigation restrictions during a drought. And this drought, excuse me, this study looks at what mandatory and voluntary irrigation-focused restrictions have been implemented and are likely to be implemented in the future by North American water providers. So recently, we know in California and Texas, a number of places have gone through pretty severe drought, and so we had some pretty good recent experience that we can look back on. And so we're cataloging sort of the variety of flavors of different restrictions that have been implemented, and then we're trying to look at, okay, what happened. So for each of the different utilities we've got participating, we're constructing an elaborate timeline that includes the period leading into the drought, what they were doing before the drought, then how their messaging ramped up and changed, how their demand then changed over time in response to that messaging, and then in response to whatever mandatory or voluntary measures were put in place, and then tracking them all the way through, hopefully through the point where the drought breaks and demand increases again, and maybe returns to normal, maybe doesn't. As a lot of cases we find that it doesn't. So this again will be more of a case study focused research that's with utility by utility focus, but also an effort to apply a rigorous, regularized approach to help us understand what goes on across utilities and what sort of common stories there are. Also interested, of course, in the longevity. So is there a real bounce back once you release the customers to use water as they will again, or do they continue to use less water than you expect or hope, even in some cases? So another excellent list of participating water providers from across really the Western United States in this one, and really appreciate a lot of the California agencies that went through some pretty severe pain and willing to step up and share some of the stories that they learned, and getting forced to get mandatory 20% restriction reductions, some cases more than 20%. For some of them, it wasn't hard. They were pretty close there to what they had to do already. Others, it was pretty severe, dramatic effort. So this project was also put out for bid. Got quite a few excellent proposals. It was awarded to a consulting firm based in California called Western Policy Research and a partner group, Madaus Water Management. The project's being led by Anil Balmazai, who's a PhD researchers, have done a number of interesting projects related to drought and also to water demand, including a demand hardening study that the Alliance published a couple of years ago. So this project should be coming up about the same time, even though it was funded a little bit later. The timeline is faster than the other project, and so I would expect that it will be coming out about the same time as the first one. So that leads us to the third project that I wanted to talk about, and really the final one for the webinar before we can get into some questions, and that is the study of peak day water reduction. And this is a project that I led for the Alliance for Water Efficiency and over the past year, and it's one that's just actually been published in the American Water Works Association Journal this month, and I've been out on the road talking about it. So it's kind of interesting. It's a small project in terms of the number of participants, but I think we might look back on this one and say, that was really the start of something new, because I think this is the first time that we're seeing the Internet of Things and sort of the real high-tech potential future world of devices that are connected to the Internet and could be potentially managed in a harmonized way to try and achieve particular utility objectives. So in the water world, or the water utility world, the peak day, or the maximum day of water use, that occurs is often of critical importance. You have to design your water system to be able to produce enough water to meet that customer demand. And we know that the peak days in most Western cities, and frankly in many cities across the US, even in the East Coast, where there's outdoor water use, it's a summertime peak where everybody turns on their automatic irrigation system at the same time. That creates the high peak demand. And this actually is data that comes from an East Coast provider that shows, some of the spikes that occur over the course of a day or a year or several years of water use. Now, what if you had the ability to reduce that, to say, turn off that faucet to the tune of a couple of million gallons a day, maybe for a few days a year, or maybe it could even be 5 million gallons a day if it was a larger place. What would it take to do something like this? So that's really the starting point of the peak shaving study. We did not come close to shaving that volume, but that's what we're heading for, I think, in the future, and sort of the hypothetical concept. So the idea of shaving demand or shedding demand is really not new. It's just brand new to the water sector. The energy sector, the electrical energy sector, has done this for years. Really, I heard about it in the 70s, I think. Typically focused on irrigation, on air conditioning. So in the summertime on the East Coast, hot climates, everybody turns on their air conditioners, and they suddenly have the highest demand for electricity of the year at that point. And so they developed these programs where they would put a small device on people's air conditioner that it didn't turn it off, but it turned it down, and it reduced the effectiveness. And people would put up with that in exchange for a break in their rates or some other concession. These programs have been highly successful. And they also have enabled the electric utilities to avoid having to build additional capacity, so generating capacity. So that's significant. And in the water industry, we have the same issues where we wanted to avoid building extra capacity for water treatment just to meet some super high summer day peak demand caused by everybody turning on the irrigation system at the same time. We can be smarter about it. We can orchestrate the timing of water demand and in the future, even as customers come on board. So that's sort of what the idea is. So what started this whole thing for me was 2015 at the Water Smart Innovations Conference in Las Vegas at the exhibition hall, where I met the Rachio company for the first time. They are a Denver-based technology startup. Maybe you've heard about them, but they have a smart internet controller that is entirely programmed through your phone, and each of their devices has an IP address, and each device can be controlled from a central location. So I had studied smart controllers as part of the California Research Initiative. I had never seen one, though, that had the internet connection like the Rachio, and the potential to be used sort of as a central hub for control. So I asked them whether they were interested in doing some research, and they said, yeah. So this is what it looked like, their device looks like, and it's what the app looks like. So I invited them to try and do a research study, and we connected with New Jersey American Water, which is a company that serves water right on the coast of New Jersey. I don't know if those of you from the East Coast, I recognize one name on the phone who knows where Rumson, New Jersey is, Eileen Flax. It's a nice part of New Jersey, actually. It happens to be Bruce Springsteen's hometown. And it also happens to be a place where they irrigate a lot, have a lot of big lawns, and have a lot of summertime demand. So New Jersey American Water thought that'd be a great place to do the study. Unfortunately, that's also a place where there's a lot of millionaires, and it's harder to give away irrigation controllers in this place than one might expect. But we did it. And so we worked with these folks. We recruited participants. We got 15 sites for our pilot study in 2016, completed the installation, got everything set up, and we got everybody to agree that we were going to shut off their irrigation systems on 2 designated days during the summer of 2016. And so then we worked with New Jersey American to develop these 2 particular, what we called peak shaving or peak management experiments. The week before, we selected the actual day by looking out at the forecast weather and trying to pick the hottest day of the week. And so we ended up picking first August 19th and then August 26th. We then provided some advance notice via email that we were going to do the experiment and warn the customers. And then all the irrigation controllers were shut down remotely from the office in Denver, even though they were all installed in New Jersey. And so then so it was very successful for 14 of the 15 homes. In each case, we had one different customer each time do a manual override. So this might be a little hard to see unless you're really staring at your screen hard, but you can see down here, the max temperature shows that the day of the experiment in each time was the hottest day of the week, got up to almost 94 degrees, 95 degrees. And then the O means that there was no irrigation. The X means that, irrigation did occur, and we determined by downloading data from the Rachios that it was a manual override by the customer on those particular days. So that's what happens when you do research in the wild. As they say, things like this happen. But overall, we thought it was a pretty good success. So that was sort of the actual ta-da. We did it. Very small start, but we actually controlled the irrigation and got customer buy-in. So the next thing was to try to figure out, okay, well, what did we actually do? So I got the billing data from New Jersey American and started to crank on it with a graduate student from the University of Colorado. So for each of the 15 customers, this is just imagine on the screen, you got 1 through 15 for these houses in New Jersey. We use their monthly water use to try and separate out their indoor and outdoor, what we call their seasonal and non-seasonal use. The blue being the non-seasonal, the indoor, the green being the seasonal or the outdoor. So then we knew we had a pretty good idea of the outdoor. And then we started to focus in on the particular month of the year where the experiment had occurred, and we were able to estimate the volume of irrigation water used each day by each of these customers, and it was quite variable actually. So we had the smallest, lowest water using customer only used about 500 gallons in a day of irrigation, but the largest used over 5,000 gallons. So that was a big yard. A big run of the irrigation system capable of using over 5,000 gallons at one time. So this gave us an idea of the potential load that we would be shedding or eliminating through cutting irrigation at these different sites. Then the next thing was to actually try and think about it on a per zone basis, because we had big zone, big systems, small systems. So one of the ways that you might do a better job of estimating the future peak shaving potential is the number of zones under control. So the volume per zone varied from just under 100 gallons to just over about almost 400 gallons per zone. Not a little bit tighter range, but than the gallons per day per system, but definitely tighter and perhaps more useful, predictive for future peak management use. So then we basically, using these numbers, we were able to come up with a range estimate of how many different types of sites it might take to shave or shed 1 million gallons of demand on a hot day in the summer. And it actually, the results are kind of interesting. So a six zone system is fairly small, very small residential system. An 8 zone is more sort of average, medium, and then 12 zone would be a large residential system. So, but if you can imagine, maybe an 8 zone system represents a mixture of what you might view out there. it's somewhere between 500 and 1,500 in that neighborhood of sites could be capable of shedding 1 million gallons. That's actually not that many. So I mean, if you think that maybe you could double that, so you'd have 1,000, or maybe you had 3,000 out there, customers in a utility, you could potentially have the ability to rearrange demand in a sophisticated way, moving couple million gallons, maybe as much as 3 million gallons if necessary, from day to day. The idea is not necessarily to reduce water use, to like we think about with sort of regular water efficiency, like you want to use less than you used before. The idea here is more as like, can we change the timing? Can we make it so everybody doesn't start the irrigation system at the same time? Can we move it so that these guys don't all water on this day at 5 in the morning, or we spread it out across town? That's I think more of the objective thinking about with this type of system. The other times that it could be potentially useful would be in an emergency situation, in a fire. When there's a fire, a utility often will want to make sure that all the irrigation systems in the neighborhood are shut off so that they can have maximum water pressure to fight the fire. Like a system like this could also be useful in that respect, or if there was a main break, other reasons you might want to shut systems down remotely. So the conclusions from this initial pilot study were that, it's pretty promising. We had the small sample, but we were able to do it. People were pretty willing to get, in exchange for a new smart controller, to give up a little bit of control a couple days a year. And I think with even better marketing and communication, and also if you didn't have to shut everything off, that's the other idea. It's like maybe you could just, shift certain zones, do things in a much more sophisticated way. I think people would be willing to cooperate, especially if they understood it was helping to keep water bills low, and avoid building a new treatment plant or do something like that. Obviously, we've got to do a lot more research. This is what we say the bleeding edge of this type of thing. But it's pretty exciting. I think there's a lot of potential, and I think this is just the beginning. There's going to be a lot more devices that are connected to the internet that use the resources of different kinds, that use water or measure water. And I think that's real exciting. We'll see how they get used, and if we can use them to help us manage, some of the bigger resource problems that we're confronted with. That's what I'm particularly interested in. So that's sort of the summary of the work that the Alliance has done and is doing right now. I have plenty of time, I think, to answer questions, to go back to if there's any head scratching going on, or if people have any thoughts about any of the projects that we've done or anything. So thank you very much for listening, and I look forward to your questions.
Okay, thank you, Peter. If anyone has any questions, if you want to go ahead and put them in the Q&A. I don't see any questions in there quite yet, but we can wait a few minutes and see if questions start popping up. That was really interesting. Thanks. I find it really interesting that you're talking about looking at the energy sector and kind of using some of the things that they've done. The peak demand study, I had a couple quick questions on that. Do you know how there's a lot of research on time of the day that people should be irrigating in the mornings instead of middle of the day and stuff like that? I was just wondering if you could kind of comment on how that relates to the where you're shaving off the peak. If most of that stuff is people irrigating all through the day, or have those two studies kind of been put together where is that making it harder for people when they're everyone's trying to irrigate between the hours of 6 and 10 in the morning or something like that?
Well, I think it's both are true. So yes, people do, irrigate when you tell them to water, just, after dusk and before sunrise, something like that. They will do that. Not everybody does. So that's the first thing. And can it create a sort of a problem, unanticipated issue? It could, and it has actually. And that's, there's some utilities deal with this by day of the week or restrictions where and then they schedule it so that different neighborhoods are irrigating at different times on different days of the week intentionally. And that's a way that it's been managed for years, sort of the old school way. I'm thinking the peak management study might show us a way we could manage it in the future, using the technology rather than dictating the day of the week.
Okay. I don't see any questions popped up yet in there, but.
Peter, I heard software developer in there. That's sort of my ears sort of perked up. I'm just wondering about any open data, either with the Alliance or maybe other places where there's these open APIs that is sort of publicly available data that software developers could use to either aggregate or do other interesting things with.
So there's if you're interested in residential water use data, the Water Research Foundation makes available the data set from the residential end uses of water studies, which I led for them, and so those have data from a couple thousand houses collected at different time periods. It's down to the toilet flush level. It's and what it doesn't have though is long-term data, data of consumption over years and years of time, and that data is usually maintained by water utilities, and who are often willing to share it anonymously with the qualified researchers, but they're often very concerned about releasing data that might expose anybody's personal information.
Okay. Yeah, I mean, there's a movement, Asheville, North Carolina. There's a coding group here that's sort of software developers that have petitioned the city for various type of use data that's anonymized. I may be saying that wrong. Data, but essentially they're removing the identification from it, but having it open, and it's not a one-time dump. These are sort of open. Again, APIs where you've got a sort of constant flow of data that you can go and grab and then again aggregate and do other interesting things with. So I'd like to see more. I'm hoping that'll be and I'm sure it is. Now how long it takes, but I think over time we'll see more and more cities and municipal areas, hopefully, that'll be making available data like that available to the public.
Well, and then never forget the USGS data. So the USGS maintains water use of the U.S. data down to county level. It's I wouldn't rely on it for the county level, but for long-term trend data, it's pretty darn good, and could be a lot could be done with it, I think.
Yeah.
So I've stunned everybody. I already had some great lunch that they had no questions about.
Oh, I've got one here. Okay. From Brian, sounds like, what are the costs of implementing the internet link controllers, especially for the water provider? What are the determinants of who should pay for the installation?
So, that was the Rachio controller costs, I don't know, between $200 and $300, I think, for an 8-zone controller. And then there are no costs associated with it. That's it. It's just that one time, but it can only be installed at a home or a site where there's power and then where there is an internet connection. But where you've got that, then there's no cost associated with it. Then if you wanted to implement a peak management program using a network of Rachio controllers, that might cost something, I think. That's not going to, that's going to be a much more elaborate thing. But for a customer to buy the device and just use it as a smart controller, it's not an expensive device. What we're trying to do really is understand what the bigger management potential is of having thousands of these devices out within a service area, and whether the potential for orchestrating demand might be something, the utility would be interested in doing to meet particular objectives. And one of the examples that I think about would be a small town. Just imagine if they're served by an elevated water tank, and that the being able to manage demand if the tank would reach below a certain level could be also a particular interest too. So I'm interested to see what people are going to come up with once they sort of the idea marinates a little bit.
I'm curious, Peter, are those controllers wired? Do you have to, or are they wireless? Will they connect to a wireless network like inside the home, or?
Yeah, they're Wi-Fi, but the wires are the wires that go out to the zones of valves. That is a physical wire that actually plugs into the controller. Then there's no buttons or anything on it. I'm gonna go back up to the picture. There we go. Yeah, so I mean, this is just a light. The blue thing is just a light. There's no buttons on it, and all the entire programming and setup is done from the phone through the local Wi-Fi network.
So there does need to be a power, I guess, 120 volt going to this box here, but outside of that, there's no.
Yes.
Gotcha.
Yeah, so it does make it it's more challenging for like an installation in a field or right next to a park or something where you might have power but you might not have internet.
Yeah.
So you could conceivably put a cellular connection, but then it starts to get much more expensive. Things like that. But for the residential small commercial application, it's which is really a lot of the irrigation sector, at least a smaller side of the irrigation sector, it's an excellent alternative.
Okay, it looks like we do have another question that's popped up. Tom asks, I'm with a group of citizens in St. George, Utah, working with our local water district and state water resources organization, advocating for conservation and against the Lake Powell pipeline. There are many controversies and data issues. An example, comparative water use data. Whenever we try to set some meaningful targets, we hear you're comparing apples and oranges. Do you know of data sources for comparative data?
Yeah, well, yes. I mean, and I understand very much what you're saying, and the critique of that is often made. So that's definitely something that to be concerned about. I would start with the USGS data and use it to evaluate the trends in water use. So if I were to be combating an infrastructure pipeline, I would be particularly interested in showing that the trend in water use, regardless of what it was, whether it was the GPCD or whether it was the total demand or whatever it was, the trend of those things is going down. And that is really what we have found in the last 20 years as water efficiency has really set in. Even as population has increased, urban water use has gone down or maybe stayed flat if there's a high demand. It's pretty rare you find a community where their demand has actually increased substantially over the last 20 years because we've really been successful at reducing per capita consumption. Then that's the first thing is to show the trend, a declining trend. The next thing is to say, okay, how much potential is left, and to say, that maybe this trend isn't finished, and that there's additional reductions that may be achieved, and quantify, and then I think you can question whether the infrastructure is needed or not.
A follow on to that question, Brian says the USGA data on water demand seems to be only every decade. Do you know of more frequent reporting?
No, it's every 5 years.
Every 5 years, okay.
And the key, so I'm assuming that what you're interested in is the public supply sector. If it's agriculture, then yes, you're right. It's only every 10 years. But if it's public supply, they update it every 5 years, and there's a new update for 2015 that just came out. But you can really see the nationwide the curve in demand is pretty pronounced. So the thing would be to produce that for the counties or the areas that you're looking at, to show those trends. That's one thing to start. And then if people don't like those data, or they say, oh, those are no good ones, then you ask them to produce better and more reliable data for you, I would argue.
Okay. Doesn't look like, if anybody else has any more questions, put them in the Q&A box, but looks like that might be it. I did want to mention that this is, and Mark mentioned this at the first, but this is being recorded and it will be available on our CWEL website. And that is in the chat box there that has a link to where the webinars are. So that should be up within the next couple of days. While we're seeing if there's any more questions, I just wanted to mention our next month's presenter is going to be Bernd Leinauer, and he's a turfgrass extension specialist with New Mexico State University, and he'll be joining us in June. So does anybody have any more questions? It's now or never. Okay, well, thanks so much, Peter. We appreciate your time today.
My pleasure.
It looks, and Peter's email is just on this final screen here too. So if you do have any more, oh, someone's still typing. Let me see what we've got here.
Never too late.
You're not under the deadline yet. So Brian asks again, what are the costs of implementing the internet linked controllers? Oh wait, sorry, we've already done that one. When do you expect the RFP 1 and 2 results?
I think before the end of the year. I'd look to see the reports coming at late 2018, so November, December timeframe.
Okay. Sounds good. Well, thanks so much for your time, and hopefully we'll see you guys next month.
Thanks, folks.
Okay.
So long, everyone.
Bye-bye.
Thank you.